Hey people, it's Mr. Thompson with a video math lesson. Today we're going to talk about simultaneous equations, okay? All kinds of good stuff here. Simultaneous equations, not just one equation, multiple equations at the same time, okay? So yeah, let's figure out what simultaneous equations means, and that's exactly what it is. It's multiple equations considered at once, okay? Now, when we have multiple equations considered at once, what we're usually interested in is the solution. Okay, the solution to simultaneous equations is a point that satisfies each equation. Okay, there is usually just, it's also the intersection of the lines. So when you have equations, right, they represent lines. The solution is the point that satisfies each equation, and it's the point where those lines cross, where they intersect. Okay. Now, there's only ever just one. There's only ever one solution to any simultaneous equations. It's either one or none, right? Okay. Parallel lines, if they don't cross, right, then there will be no solution. There will be no point of intersection. Okay. So, some of the kinds of problems you'll see with these, first you might see some pretty simple problems that just give you a couple of equations. So y equals 2x plus 3, and then y equals negative x. These are two equations. We're going to consider them at the same time at once, so they're simultaneous equations. And we want to consider the solution. Now, some problems, they'll just give you a proposed solution. So it says, is negative 1, 1 the solution? If it is, then that point should work for both equations. So what we do is plug the coordinates in for the x and y variables, the pronumerals, in the equations, and check and see if it works. Okay, we just see if both sides come out the same. So we'll plug the 1 in for the y, okay, and we'll plug in negative 1 for the x, right, because that was our x coordinate, right, and then plus 3. And so we'll evaluate. So 2 times negative 1 is negative 2. So I have negative 2 plus 3, and on the left is just 1, right? Negative 2 plus 3 is, of course, positive 1. So we have 1 equals 1. That checks out. It does work. We're happy. Okay, so that so far so good. All right. Let's check the other equation, our y equals negative x equation. Right. So we'll plug in the 1 for the y again, right? And then we'll plug in negative 1 for the x, okay? And we have to make sure we do this very carefully. We have to write the equations exactly so that negative sticks around, and then where the x was, we put negative 1. So it's like negative, negative 1. Well, negative, negative 1, there's a double negative, and as always, that makes a positive. So 1 equals 1. So that works as well. We're happy. So what that means is we can answer yes. Negative 1, 1 is a solution to these equations. It's the solution, the one and only, right? Y equals 2x plus 3 and y equals negative x. They cross and intersect. They intersect at negative 1, 1, right? Okay, let's try another problem. Y equals negative 2x and 3x plus 2y equals 4. Okay, same thing. We just and the proposed solution is 2, negative 4. Okay, so we're going to plug this point into both equations. Okay, so we plug in the negative 4 for the y and the 2 for the x, okay, into that y equals negative 2x equation. So we do negative 2 times 2, which is, and on the left we just have negative 4, and then the negative 2 times 2 is also negative 4. So that one works, we're happy. Okay, let's try the other one. Okay, we get 3 times 2, 3 times x, which was 2, and plus 2 times negative 4. We plug in that negative 4 for y. So let's evaluate this left side, and hopefully we'll get positive 4, and that will mean that that was the solution. Now 3 times 2 is 6, and 2 times negative 4 is negative 8. Okay, and when we take 6 plus negative 8, it's like 6 minus 8, we get negative 2. Does negative 2 equal 4? No, it does not. Okay, so the answer to that problem is no. 2, negative 4 is not a solution. Okay, so that's how you do that kind of problem. If it works for both equations, as it did here, then it is a solution. If it works for either one or none, then no, it's not a solution. Okay. Now, that'll come in handy here in a minute, because the next type of problem we'll have is when we graph to find solutions, so graphing solutions of simultaneous equations. Okay, what we'll do is we'll be given a problem like this. Find the solution to y equals 2x minus 2 and y plus x equals 4 by graphing. Okay, now we're not given a proposed solution. We have to figure it out. We're asked, what is the solution? And we're going to do this by graphing. Okay, so we draw our fancy coordinate plane here, our axes, x and y axis, axes, and we label them, give a scale, use nice and straight lines, and we're going to graph each of these lines. Okay, now the first one is really easy. It's gradient intercept form, so we'll start at the intercept, plot a point right there at -2 on the y-axis, and then we will use the slope. So the slope is 2, which is like 2 over 1, so that's a rise of 2 with a run of 1. So we go up 2, okay, up, if you can't see my little red dots, we go up 2 and over 1, and we plot a point, right? And then we can draw a line through those 2 points. Okay, so that's our first line, the y equals 2x minus 2. Now, for the next one, the easiest way to graph this is by finding the intercepts. Okay, so we set each of the x and y equal to 0, respectively, and find what the other one are equal to. So if we set x equal to 0, then 0 is just 0, so y equals 4, that's our y-intercept. If we set y equal to 0, 0 is just 0, so we get x equals 4, which is our x-intercept. So the x and y-intercept are both 4, nice and easy. Okay, so we plot a point at 4 on the x-axis and 4 on the y-axis, and draw a line between those 2 points. Okay, nice and easy. Now, here's what we do. We look and we see the point where they intersect. Okay, we draw them out as far as we need to. Some lines might go way out here or whatever, and to find the intersection. This one's pretty easy. It intersects right here, and we can look and see what we think that point is. Now, here's one important point when you're doing this. You really got to have graph paper. Okay, if you're not using graph paper, probably you're not going to be very accurate with your lines and things like that, and it's going to be very difficult. So it's definitely worth using graph paper when you're graphing for solutions. Okay. Now, if I look at this, I can plot a little point, my little red point here, where I think the solution is. I think that looks like the point 2, 2, right? Over 2, up 2, right from the origin. So the point 2, 2. Now, do we know for sure that it's 2, 2? No, we don't. All we're doing is kind of guessing and looking. But what if it was the teeniest, tiniest bit off of 2, 2? What if it was 2.01 and 2.01 or something like that, really close to 2, 2? We don't really know. By looking, we can't be infinitely precise when we graph lines. But what we can do is use our skills that we did before, where we check this solution. So we can plug the point 2, 2 into each of our equations. So we plug in 2 for y, 2 for x, and we evaluate. So 2 times 2, so this is that blue equation, obviously. 2 times 2 is 4, so 4 minus 2 is 2, so 2 equals 2, so that's great. So far we're good to go. Okay, let's check it with the other one. We plug in 2 and 2 for the x and y, and hopefully everyone's familiar with that 2 plus 2 equals 4, okay, which of course does equal 4, and so we're happy. That point worked in both equations, so we can definitively say that the solution is 2, 2. Okay, we had to graph it because we didn't want to just guess numbers to plug in here, right? Okay, unless you know some other methods, which there are, but that's another video coming probably some other time. But we graphed it to see what we thought the solution was, and then checked it. Okay, and so now we know that actually is for sure the solution. So we're done. Best of luck, and see you next time.